Okay, everybody, welcome to today's lesson of simplifying ratios. So, as we can see from this introductory screen that we've got on the screen right now, last lesson we did introduction to ratios, okay? So we talked about all the things that ratios do in terms of forming them, maybe turning out into equivalent ratios, and all of this here, okay? We think of ratios in parts, therefore if we have a ratio of 1 to 3, that has 4 parts, and how to make an equivalent ratio by timesing or dividing by the same number. So that was yesterday's lesson, or sorry, previous lesson. Today we're going to be talking about chapter 6b, which is simplifying ratios. Okay, so we are simplifying ratios today. Now, simplifying ratios is actually kind of the same thing that we do when we simplify fractions. They're very similar in terms of the methodology in which we are going to take into account. So, just like we can simplify fractions, we can also simplify ratios by, how are we going to simplify? Well, we divide Please excuse the school bell there, I'm sorry guys. Dividing each term by a common factor. Okay, so just like we can simplify fractions, we can also simplify ratios by dividing each term by a common factor. Okay, so we're going to talk about some examples of that later on, but we can also do this in terms of fractions or decimals. If a ratio is in a fraction or a decimal, we don't like ratios in fractions or decimals. It's not going to be very nice to deal with. We want them as whole numbers, okay? So just get a ratio in simplest form and it's in fractions or decimals. It can be simplified if we have a number that is a decimal or a fraction. We want it to be whole, so we want it to be bigger. How are we going to make it bigger? Well, we're going to multiply it. So we're going to multiply by a number to simplify. So we'll go through some examples of these and what we're going to be doing to simplify them, okay? But let's first get into what I like to call my definitions, my little rules on how we're going to do these. So the first one, and that is to simplify a ratio. To simplify a ratio, we divide each number in the ratio by the highest common factor. We divide each number in the ratio by the highest common factor. Highest common factor, of course, also being represented here has HCF because I don't want to write highest common factor every time I talk about it. So let's say we have a ratio of 15 to 30. We're going to identify pretty quickly that the highest common factor is equal to 15. So we're going to do what we usually do. We go down like this. If I divide this side by 15, I have to divide this side by 15 as well, okay? We can't just do things with one side to ratios, we have to do something to both sides of our little colon. And that is going to give me 15 divided by 15, which is 1. And then 30 divided by 15, which gives me 2. Okay, so the ratio from 15 to 30 is going to be simplified down from a ratio of 1 to 2. It is proper convention, so it's usually accepted, to express ratios in their simplest form. In their simplest form. Simplest form. Now, I know last lesson you guys asked me if you would always have to simplify ratios, and I said no. Well, that's because I really wanted to get you guys into the habit of simplifying today and not, okay, what if I'm messing it up? I wanted to show you the methodology before I showed you the steps. So, is it proper convention to express them in their simplest form? Yes, you should usually simplify, but sometimes questions will ask you not to simplify. Sometimes they'll ask you to leave them as the numbers. So just be aware, read the questions, and know what you have to do. Ratios in their simplest form are expressed in whole numbers. Whole numbers. Okay, so we don't want ratios in fractions or decimals. We want them as whole numbers. So for example, if I would have a ratio now, let's say something 2 to 1/3. Okay, well, you don't want it as a fraction, you want it as 1/3. Again, guys, apologies for the school bell. I'm not doing this at home, I'm doing this at school. So, something a little bit different. We would want that to be expressed as something else. First, what we do is we would write 2 as a fraction. Okay? So we express 2 as a fraction. This little arrow here to represent 2, 2 to 1, 1 to 3. And then what we do is we multiply each fraction by the LCD. The LCD, the lowest common denominator. So the lowest common denominator between 1 and 3 is obviously going to be 3. So I'm going to times 2 over 1 by 3. I'm going to times 1 over 3 by 3. Times by 3, times by 3. 2 over 1 times by 3, well, that's going to give me 6 over 1, which just gives me a 6. And 1 over 3 times 3 gives me 3 over 3, and that is 1, which gives me a ratio of 6 to 1. If I was to go back to my original ratio, so my 2 to 1/3, you see that there are 3/3 in one whole number. So for every one whole number, there are 3/3. So for two whole numbers, we should expect 6/3, which is what we can now see in our ratio below, our final simplified ratio of 6 to 1. We should have 6/3, we should have 1/3 for every two numbers. 1 part to what should be 6 parts. Okay? And then finally, before ratios can be simplified, they need to be in the same units. We always want these to be in the same unit. So comparing the same thing to the same thing, all right? You're not going to compare something like a bunch of apples to a single banana, okay? That won't really work. So you want to compare the same sort of unit or quantities to the same thing, okay? So they're all of our rules that we're going to talk about, so make sure that you're all copied this down. And while that's happening, I'm going to start some examples, okay? So now we're just going to be talking about simplifying ratios. Some examples. So, I hope you guys aren't missing me too much while I'm gone, but don't worry, I'm thinking about you while I'm away. I'm not. But let's just hope that you think that. So we have simplify the following ratios. A, let's go 7 to 21. So the ratio of 7 to 21 can be simplified by first identifying the highest common factor. The highest common factor between 7 and 21, well, that is just 7. So now I'm going to divide each side by 7. I found the highest common factor. I divide each number by that said highest common factor. Okay, 7 divided by 7, that's easy enough. That gives me 1. 21 divided by 7, that gives me 3. So my new simplified ratio is 1 to 3. For my next question, simplify the ratio 270 to 450. Well, what is the highest number that goes into both 270 and 450? Well, I can tell you guys that the highest common factor between those two numbers is equal to 90. If you can't find the highest common factor straight away, I'll talk about that after I finish this example. But you don't have a problem if you can't identify it either way. You could just do it step by step. But right now I'm just going to do the one step. So I divide each side by 90. That's going to give me a ratio of 3 to 5. And they're my new simplified ratios, just by dividing by a whole number, okay? If you couldn't pick it straight away, so if you can't find the HCF, straight away, again, that's really not the end of the world, because as we are dividing each time, all we're going to do is keep dividing and dividing and dividing and dividing. So let's just write our same ratio again, 270 divided by 450. And I'm like, oh, hey, look, 3 goes into there both times. So let's divide each side by 3. Divide by 3, divide by 3. Well, that's going to give me 90 to 150. Right? Okay, and then you go, oh, wait a minute. Well, I can get 3 into that again. So let's take 3 out again. Divided by 3. Divided by 3. Sorry. Divided by 3 again. 90 divided by 3. Well, that gives me 30. 150 divided by 3, that is going to give me 50. But wait one more, because there's still one other common factor that I can take out, and I know that that's going to be 10. So now, again, I'm going to divide both sides by 10. 30 divided by 10, you guys should know this one, it's 3. 50 divided by 10 is 5. Apologies for the bell again. And now we have that final ratio of 3 to 5. Well, look at that. It's the same as what we had before. So you can see it doesn't matter what way you get there. You could do it by straight away identifying the highest common factor. Oh, sorry. You've probably all been thinking, shouldn't that be 90? That should be 90. My fault, I just fixed that. So the highest common factor was taken out to give me 3 to 5, or you could take it out as a multiple of factors on and on and on, step by step, and that's also going to give you that 3 to 5. So 3 here, and then your 3 here, and then your 10 here. Okay. Now that is simplifying ratios by dividing when we had whole numbers. Now we're going to simplify ratios where we have fractions. So now we have the ratio of 3/5 to 1/2. Now, first off, we need to try and identify the lowest common denominator. Remember, the lowest common denominator is the lowest common multiple between the two denominators of the fractions. So we have a denominator of 5 here and a denominator of 2 here. So the lowest common denominator is going to be 10. Now I'm going to times both of my quantities here by that same number. And what should that same number be? Myself pausing for effect because I want you guys to get the answer. The answer is going to be 10. So multiply that side by 10, multiply that side by 10. So 3/5 times by 10, well, that's going to give me 30 over 5, and 30 over 5 is 30 divided by 5, which is 6. 1/2 divided by 10, well, that's 10 divided by 2, and that is going to be 5. So that simplified ratio is now just 6 to 5. And another example now we're going to move on to. Example D. So we've got 3 1/3 to 1 2/5. We don't like mixed numbers when we're talking about ratios. We don't like fractions when we're talking about ratios at all, but we really don't like mixed numbers. Whenever you see a mixed number, always change it to an improper fraction, okay? And if you don't remember how to do that, don't worry, we're going to cover it now. So, for a mixed number, actually I'm going to start by just putting this here. Always change mixed numbers to improper fractions. Okay, always change mixed numbers to improper fractions. How are we going to do that? So 3 1/3. Well, what you do is you multiply the denominator by the whole number. So you multiply them together, and then you add 1 at the top. So you multiply 3 and 3, and that's going to give you 9. 9 plus 1, well, that equals 10. So your numerator of your improper fraction is going to be 10. And then you keep the denominator that you had. You multiply the denominator by the whole number, then add the numerator on to give you your new numerator, and then you keep your denominator the same. So it should be 10 over 3. So now we just figured that one out, so we're going to rewrite my part D as improper fractions. That is now 10 over 3. Using that same method we just used, let's figure out this 1 2/5 as an improper fraction. 5 times 1 is 5, plus 2 is 7, so that is 7 over 5. Now, remember before we had to try and find the lowest common denominator between the two quantities and then multiply each quantity by that lowest common denominator. Well, 3 and 5, the lowest common denominator is going to be 15. So we're going to multiply this now by 15, which should give me my new simplified ratio. Because we always want ratios in whole numbers, we don't like these fractions or decimals in here. We want them as whole quantities to whole quantities. 10 over 3 divided by 15, well, that's going to give me 150 divided by 3. 150 divided by 3 is 50. Okay, and 7 over 5 times 15, well, 7 times 15 is 105. 105 divided by 5 gives me 21. So now we've got 50 to 21 as my new simplified ratio. Then the last example we're going to talk about today, again, I wanted to go through a lot of examples since I'm not going to be here to make sure you guys are definitely getting this content. So, 3 kilograms to 450 grams. Okay. Now, previous lesson, I talked about, well, you don't usually see ratios with units. Well, sometimes you do. It's not impossible, so maybe just get used to seeing it like that. So 3 kilograms to 450 grams. Remember, we always have to compare ratios only if they're in the same unit. So if these two ratios right now are in kilograms and grams, we need to change one of them because we need to both have them in the same units. Since we don't like decimals, if we were to use kilograms, this would be 0.450 kilograms. And either way, we would have to change that because we don't use decimals in ratios. So it's going to be easier to just change the kilograms to grams. How do you change from kilograms to grams? Well, you go 3,000. So now they're both in the same units, they're both in grams. So it's 3,000 to 450. Need to be in the same unit. Okay. And now again, it's just a matter of finding the highest common factor between these two numbers and then dividing by it. For the sake of me just getting to the answer, because I'm not here to try and lead you guys there, the highest common factor is 150. So we're going to divide both of these by 150. 3,000 divided by 150 gives me 20. And 450 divided by 150, that just gives me 3. So my new simplified ratio is 20 to 3. And that, guys, is the complete lesson today. We talked about simplifying ratios. We talked about, to simplify a ratio, you divide each term by a common factor. If it's in a fraction or a decimal, we have to multiply, not divide. And then there are our rules and our examples. So you guys are going to be more than well prepared to do this exercise. Please treat your relief teacher with some respect, like you would me. I mean, as you wouldn't me, please be nice to them. But that is all she wrote. So you guys now have exercise 6B to do in your textbooks. You know where your textbooks are. So please go get them. Please start working. Now, since we really didn't get much done this week, it's been quite a shortened week due to the PD day, I would really like you guys to complete 6A and 6B for homework at some point during the next week, okay? So not necessarily by Monday, because it is a fair bit of work, but at some point next week, I would like you to have these two exercises finished, okay? So, that is me signing off. I hope you guys have a great weekend, and I will see you when I get back.